Hi everyone. We are just going to wait a few minutes for more people to come, but I have put the link to the course feedback survey in the YouTube chat, so please take some time to fill that out while you're here while we're waiting for more people to come. For those just joining, please take a minute to fill out the course feedback survey. The link is in the YouTube chat, and we'll start in a few minutes. Hey everyone, welcome. As people are coming in, please just take a minute to fill out the course feedback form, which is in the chat. Sorry to repeat this for the people who've been here for a few minutes. That feedback form is really, really helpful to us. This is both me and Katie's first time teaching this class, so this feedback is really helpful to us in if we teach it next year, designing it and making it even more useful. There's a question about, is this the pace of a regular Chem 1A class? I don't know.
Yeah, that may be a better question for the tutors because they actually experience both this and Chem 1A, and that probably also varies a lot by professor.
I would also say that Chem 1A has lecture and discussion section, and we don't have that. And so I think like the lectures in Chem 1A might honestly be a little faster than this, is my perception. But then they have discussion section, which is like an explicit time that you are expected to go to like go over it again. So the lectures might be a little faster than this, but there's also more other stuff going on, more like other resources and ways to make sure you're staying on top of things. But it's also hard because we went really fast to cover like all of high school chem in 3 weeks, but that material is a bit easier than the material that's covered in Chem 1A, so it might be slower because like slower in terms of like number of things covered in an hour, but faster in terms of like how hard those things are total. So I don't know. Sorry, that's not like a...
Yeah, definitely ask the tutors. They would probably have a better answer. And maybe they had the same professor that you all will have in the fall.
Yeah. Okay, so let's go ahead and get started. We just wanted to give you our best advice for success, because both of us have been GSIs multiple times for engineering classes. For us, that's within CBE, but the experiences are similar across majors. And so we've seen a lot of students succeed and have issues in our classes, and so we just wanted to give you guys sort of that perspective and the best advice that we've gotten from doing that. So I remember coming into college and not really even knowing what a GSI was, because that's not really a thing in high school. So there are some exceptions, but for the most part, your GSIs will be PhD students within the department of whatever class you're taking. So your Chem 1A GSIs will be chemistry grad students for the most part. Some classes have undergrad GSIs who are like juniors or seniors in that department, but most of the GSIs you'll have at Berkeley will be PhD students. And that means that most likely they got an undergrad degree also in that field or in a related field. So you can definitely go to grad school in a different department from where you got your undergrad degree, but most at least have an undergrad degree in a very related field. So what that means is that we have been where you are, and just because we've gotten more comfortable with the material now, we definitely remember when this was really hard for us when we were learning it in undergrad. And so I think a lot of undergrad students really think like my GSI is going to judge me for like not understanding this because this is so easy for them, and that's like definitely not true. I guarantee you that your GSI has like gotten a below average grade on a test, probably both in undergrad and in grad school, or even like done poorly, like gotten a C in a class within their major in undergrad. So definitely don't be afraid to admit that you're struggling, because like I definitely remember in undergrad going to my GSIs and being like, what on earth is going on in your class? And that is fine. We also do research every day in this field, which means that we potentially have a useful perspective for you on like, when do you use this material? How does this material connect to real life things? Because it can sometimes feel like the material you're learning, like why do I care like what electron orbitals are happening right now? And so we generally like use this material a lot, so the GSIs can like provide a useful perspective on that. We also get paid to do GSIing, or it's like a part of our funding package for being a grad student. And so what that means is that we are expected to spend sometimes 10, sometimes 20 hours per week GSIing. And so this is like a part of our job, and you shouldn't feel like you are a burden asking for help, because it's literally our job to help you. So it's not like we're just like, as GSIs in your fall classes, are just like volunteering and you should like leave them alone as much as possible. Like this is literally part of their job, and you should not feel bad asking your GSIs to do their job and help you. Like we want to help you. So related to that, like we are really, really trying when we show up to discussion section or office hours, like your GSI is really trying to be as helpful as possible. And so that means that like if there's any feedback you have or any questions you have that would make the class more useful to you, you should ask. I once had a student like at the very end of a semester say like Lorena writes too small on the chalkboard and I never could read anything the entire semester. And I was just like, no, like if you had just told me, like that makes me really sad to hear that at the end of the semester when like I really wanted you to be able to learn from me. And so like I would really, as a GSI, like really appreciate students being like, hey, can you slow down? Like I'm confused, because that means that I can be more useful. And then also, as always with any lecture, like please throw questions you have in the chat. So the other thing I wanted to say about classes is that for most classes, you'll have a list of prerequisites ahead of time. If you have fulfilled those prerequisites, that means that you are the person that the course was designed for. So I think people are often sort of like, you're assuming, like the professor is assuming this knowledge and I don't have it, therefore like I'm unprepared, I'm stupid, I am like I don't belong in this class. But that's not true. If you've fulfilled the prereqs, like it is the professor's job to make sure that anything else you need to learn, they teach you. So I think that confidence of like, I've fulfilled the prereqs, I've done everything I was supposed to do to be here. Therefore, if I have a question, it's a reasonable one. And it's probably that the professor or GSI is assuming knowledge that they shouldn't. Um, so I think just keeping that in mind, that if there's something you don't know, it's not your fault, it's the professor's fault, it's their job to know what the prereqs are and to teach you at that level. So let that knowledge like empower you to ask those questions. That said, if you haven't fulfilled all the prereqs, that doesn't mean that you are you shouldn't be in the class, but it does mean that you should talk to your GSI as soon as possible, as early as you can, just to sort of say like, hey, I think most people in this class have taken calculus and I haven't. Do you think that's going to be okay? Like, is there any review material that you think would help me prepare? And then also, it's not necessarily true that the more you've sort of over fulfilled the prereqs, the better. I've definitely seen students be like, okay, I've seen some of this material before. This material is easy. I'm going to skip a few lectures. I'm not going to do this problem set because like I know it already. And then they sort of don't realize when the new material that they haven't seen before starts. And now they're sort of in a habit of skipping lecture. They just think of this class as easy and they don't show up anymore and then actually end up doing poorly. So honestly, I think the place you want to be is where you have fulfilled the prereqs, but you haven't like taken this class before and gotten an A in it, and you're just like looking for an easy class, because that can be confusing to figure out what material is new. So if you have like over fulfilled the prereqs and like taken a very similar class before, like you have previous knowledge, that's great, that's useful to you, but just be careful not to sort of zone out and think the class is easy and then show up to the midterm and be like, oh shoot, like I didn't realize that they had taught us this. Yeah.
Cool. So before class even starts, there are also a few things that everyone can do to kind of help set yourself up for success. So the first one would be to read the syllabus. So often this is available beforehand on the B courses page for each class. So most often instructors will publish these pages and have some basic information on them well before the class starts. So it's kind of up to you to seek out this information, but we really encourage you to do so and just familiarize yourself with what is in the syllabus. So it's really common that on the first day of class, professors will go over the syllabus and then you can ask questions about it, but still it's a great idea to read it over first. And then you would also want to get all of your textbooks, your iClickers, all of the other materials that you will need for class before the class starts. Some classes can go really fast and they will expect you to already have the book on day one, so that if they assign homework on day two, that you will actually be able to do it because you have the proper materials. The library and things like that are also other resources to get textbooks too. So yeah, there's quite a few options for how to get these materials. And then again, take a look through the B courses page. So often there is quite a bit of information hidden in all of these different folders, but make sure you familiarize yourself with the layout, know where assignments are posted, know where the discussion chats are and the forums. That's really great to make sure that you know all of the features in B courses so that you can actually use them to try to like learn the most you can. And then if you anticipate any homework submission issues, try to take care of that before the class even starts. You know, for example, if you are living in another time zone right now, and you see that the homework is due every day at some time that just isn't going to work for you, you know, feel free to note that early on and then reach out to the professor or GSIs before class starts. That's completely okay to do. In fact, I get emails all the time from students before classes start related to some of these logistical issues. And then similarly, you want to kind of resolve any schedule issues, especially right now, given how kind of complicated everything is with COVID-19 and kind of how uncertain things are. And then just like what Lorena talked about, kind of review some of the material that's required in those prereqs. So if you feel a bit worried, maybe you think that you didn't have the strongest calculus background, but you see that the class you're about to take requires calculus, open up some old notes, look through some videos and other lectures on the internet, and try to kind of refresh that material in your head so that you can get some more confidence in how you'll do in that class.
Yeah, so really the point of all of that is so that you can hit the ground running, because it's a lot easier to prevent you struggling in the class by sort of hitting the ground running. Like if you sort of have homework submission issues or schedule issues such that you can't go to the first lecture and can't submit the first homework, you're definitely like, you can come back from that for sure, but it's a lot easier for you if you can prevent that problem in the first place. So I'm really a strong advocate of sort of trying to be proactive about preventing issues, instead of just responding to them. Well, of course, if you have gotten to the point where the issues have happened and you need to respond to them, do so. But it's always best to prevent if you can. So the first thing is, it is so common to see students cheat on homeworks. A lot of times, professors are like reusing homeworks and you can find solutions, or, there's all of those internet resources out there where you can find solutions to the homeworks. And there's a lot of reasons not to cheat on them. One is that you could get suspended, and I'm sure that no one wants that. And you, whoever's paying your tuition, probably would not be thrilled. And obviously don't cheat on anything else for that same reason. But specifically with homeworks, homeworks are really your best practice and your best preparation. And so if you just looked up the answers to the homework, you've really lost a good resource that you had for studying yourself. So really make sure that you're using those homeworks. And similarly with academic integrity, when you're working in groups, make sure that every member is an active contributor. You don't really want to be on either end of the spectrum of you're kind of coasting by because you can learn a lot from those projects, so you should be participating. But it's also not fair to you to be the one person doing the project by yourself, because you can make mistakes, and also just because that's not what the professor wants. They want everybody working together. So for projects and for homeworks, both for academic integrity reasons and for your own learning, make sure you are actually knowing how to solve the problems before you turn them in. So for most classes, you should ask, it should be on the syllabus and everything, but for most classes, in my experience, you're allowed to work together on homeworks, and it's honestly encouraged. I've taken many classes where it's actually impossible to solve the homeworks by yourself. But that doesn't mean Katie solves problem 1, I solve problem 2, and we just tell each other the answers. It maybe means Katie works on problem 1, I work on problem 2, and then Katie kind of talks to me and helps me through problem 1. But what I'm writing is my own work. I know how I got from step 1 to step 2 by the time I turn it in. And vice versa. And so it should never be Katie did the whole homework and I go up to her and I'm please teach me how to do every single problem on this. That is not fair to Katie, and it also hurts my own learning because I never sort of thought about it myself. Pay attention. I know that this is sort of obvious, but it's definitely frustrating, as a GSI, when you go through the syllabus on day 1, students are on their phones in class, and then that night they're oh my god, how do I turn in the homework? And I'm well, I just told you. And similarly, with the material, If something is unclear, like you can totally ask the GSI to like explain that again. But sometimes it's sort of like, I will say like, I am plugging in 5 for X because whatever, and like someone's on their phone, and then they're like, wait, why did you plug in 5 for X? And it's like, if you were actually confused, that's fine, but sometimes it's clear that students are just sort of not paying attention. Yeah, it's just a point of respect for your GSIs, but also for your own sake. Don't let yourself get behind. I think, especially with online learning, it's like really easy to be like, well, the lectures are posted online. I can just watch like all of them the day before the midterm and like that'll be fine. You will not. You will not watch all of the lectures the day before the midterm, and you'll also then sort of automatically be like struggling on the homework. So just really pay attention, stay on top of things. And ask questions. So similarly, like going back to those prereqs, you should have the confidence that you belong in the class. And if anyone else, if you have a question, someone else has that question. So you've all been really great about asking questions during prep, which is a really good sign. It's really, really important to ask questions, and just know that questions are not annoying. Questions are helpful to everyone in the class, and they're helpful to the GSI to know what's confusing. And like, we make mistakes. So it's not necessarily, sometimes the question is like, where did the negative sign go? And the answer is, I forgot to put it there, thank you. So asking those questions is super useful, super important, both for you and for your classmates. So definitely get in the habit of asking those questions and don't like feel like a burden by asking questions. And then, yeah, like I said, with struggle prevention versus response, I think a lot of times there's a shame component where people are embarrassed that they're struggling or that they've gotten a little bit behind or that, homework 1 is hard. And so they don't ask. And then homework 2 is really hard, and then homework 3 is really hard, and now it's the day before the midterm, and you sort of come to your GSI and you're like, nothing you've said from day 1 has made sense to me. And if a student like came to me like that, I would totally sit down with them and try to help, but it's going to be a lot harder to sort of get you caught up on a whole half a semester in a day versus if you came after homework 1 and were like, hey, I was like really confused on this, and then we can sort of get you back on track after homework 1, and then homework 2 can be easy and doable for you. So at whatever point you start struggling, definitely ask for help. And if that is the day before the midterm, ask for help. Don't feel like it's too late. But the earlier you do ask for help, the better. And then the last sort of thing for struggle prevention is office hours. So before we get into office hours, I want you guys to take a couple minutes in your breakout rooms, chat about what you think office hours are and what they're for and why you might go, and throw any answers you have that you like into the YouTube chat, and then we'll talk through them. So just take a few minutes to talk about like why might you go to office hours, and then put your answers in the YouTube chat. Yes, I'm seeing in the chat that it's fewer people. That's definitely true. If you have a big class, there's definitely not going to be 100 people in your office hours. So it's sort of a higher teacher to student ratio for answering questions, definitely. Any other reasons? It could be more personalized help. Yeah, totally. In discussion section, it's sort of not me working one-on-one with you on like what you in particular need the most help with. It's kind of what the class as a whole needs the most help with. Whereas in office hours, it can be a lot more personalized with exactly where you personally get confused, for sure. So maybe let's do like 30 more seconds to put, think of reasons you might go to office hours and put those in the YouTube chat. Yeah, so someone put in office hours is a great way to get to know your instructor and network with them, totally. I'm going to talk about that on this slide, but that's a really important thing for sure. Especially now that there's like this semester with less in-person interaction, it's a really great way for your instructor to get to know you. Okay. Feel free to add more in the chat. I'm going to go through sort of the ones that I thought of, but there are sort of an infinite number of reasons to go to office hours. Probably the most common one is for help on solving the homework. When I have office hours, probably 80% of the people that come to office hours are just sort of like, I'm stuck on problem 3. Can you like walk me through how to solve it? And that is totally fine and totally reasonable, and I expect that in my office hours. But I think there's a lot more that you can get out of office hours. One is sort of more broadly problem-solving strategies. So as opposed to just how do I solve problem 3, like in general, how should I approach problems like this? Like how did you know to get from step 1 to step 2? What's a good starting point for problems like this? And then even more broadly than that, just sort of conceptual questions about the material. And I think one thing that is really useful about office hours that some of you have said in the chat is sort of realizing you're not alone, other people are struggling as well. And so that can also look like sort of working with your peers on the homework or on those problem-solving strategies. A lot of times at office hours, you know, if there are 10 people, I'm not talking to each person one-on-one all at the same time. So I sort of say like, oh, you know, person 1, I actually just explained how to solve problem 3 to person 2. Maybe you guys can work together on that. So I think it's a good way to work with your instructors, but also with each other. And so that goes back to those personal relationships and sort of realizing that you're not alone, and that you have people you can work with on these problems. And also, like we talked about at the beginning, your GSIs are not just experts in like the material of Chem 1A, they're also grad students studying chemistry in general. And so if you ever have questions about sort of why this is useful, or even just like, I don't have any questions about the material, but like, can you tell me more about your research? Can you tell me more about like why you love chemistry? Like, did you do any internships, anything like that? Sort of broader questions, because we've really been in the field for not as long as your professors, but a while. And then a few people brought this up in the chat, so getting to know your GSI is really useful for a lot of reasons. One is it lets your GSI get to know you. So that lets us sort of, oh yeah, I remember you from last office hours. You had a problem with like this specific topic. How's that going? It really helps you get even more personalized attention and help. But also, if you want to do an internship next summer, those applications are going to be around January, which means that if you need rec letters from college classes, it's going to be from classes this fall. And generally, you want those rec letters to come from your professors, but your GSIs will help them write those letters. So if you have a really close relationship with one of your GSIs, you like came to every office hours and like you know that they really respect you and like they've seen how hard you work. Even if you don't know that professor well, you can email the GSI and say, hey, I'm going to ask Professor Smith for a rec letter. Would you be willing to like help write that? And then when you email Professor Smith, you can say like, hey, I was in your class. I talked to Lorena. She said that she'd be happy to help you write this. And they're a lot more likely to say yes when they know they'll have help with that. And similarly, on the topic of rec letters, I've seen some really bad, boring rec letters that say, you know, so-and-so turned in all their homework on time, got 100% on all their exams, and ended up with an A+ in the class. That's like great, like congrats, you did well in the class, but that's like not an interesting or useful rec letter. And I've seen some really, really amazing rec letters that are like, so-and-so, you know, really struggled with the first half of the course, came to every single office hour, worked really hard, and then they ended up turning their below average midterm grade into a B+ in the class. Like some of my favorite students have been students that ended up with B's and even C's in the class because I saw how hard they worked. One of my favorite students from the last course I taught got a C-. And we wrote her like an awesome rec letter because she like had come to every office hour. We saw how hard she worked. And that rec letter is like much more useful to you than one that's 3 sentences long that says this person got an A+. So get to know those professors, both because they can help you, but also because it like lets them get to know you and write good rec letters for you and be more helpful to you in the future. And so along those lines, you can ask us for advice on internships, on research, on careers. If you're looking for undergrad research, which Katie will talk about later, like we're in research labs. So we sort of have sometimes a useful perspective on that.
So one of the things about college is that often each class will only have 2 or 3 exams every semester. So what that kind of means is that often 30 or 40 or sometimes even 50% of your grade will come from a single exam that takes like 3 hours. When I first went to college, I found that so intimidating because it just put this like huge weight on every single exam I took, and there were only a few of them, so if I messed up, I didn't really have that many opportunities to fix anything. So for that reason, it's really important to spend your time studying and preparing for those exams really well. So don't wait till the last minute. You want to constantly be using tools to study all along. And one of the best ones is actually your homework. So that's why it's so important to actually do your homework. And if you are working in other groups, make sure that you're actively participating, you're always talking about concepts, and really understand how these problems work. And oftentimes, you know, you'll reach a homework problem where you just have no clue what it means. And that's totally okay. There's a lot of resources that we talked about that you can use. So all of the solutions will be posted on B courses, and you can always go through and look at those. And then you can come to office hours and go over the solutions with GSIs, even well after the homework was due. You can always ask questions about homework 1 in like November. That's completely okay. And you should feel comfortable doing that. It's really important to have these concepts down.
One of the things that I really like to do when I'm a GSI is take one of the homework problems that everybody studied with and put it on the midterm with different answers, with different numbers. I've done that a few times, so it could happen.
Yeah, I think it's also common that some of the hardest problems that we assign are on the homework and not on the exam, because that's where we know that you'll have like more resources like your peers or other textbooks to actually get into some of these long, really challenging problems. So definitely if you can solve every single problem on your homeworks and you feel really great about your understanding of those concepts, chances are you're gonna do really well in the exam. So it's like really the most useful tool you have, and to continue to seek out other resources if some of the homework was confusing. And you also can discuss with your peers. So it's really important to form study groups and other kind of resources like that so that you can go through before an exam and kind of highlight some of the main concepts and kind of just talk things over, right? There's many strategies on how to solve a problem. So maybe one of your friends has a totally different way of thinking about the same problem. And it's great to share these different ideas so that everyone can benefit from them. Because maybe their way of solving the problem makes a lot more sense to you than the way that the professor showed you. That's totally possible. It happens all the time. Everyone thinks differently. And this is a great way to kind of interact with more people and learn more. And make sure you just solve all of the practice problems you can find. So all of these classes have been taught before. You can try to find other practice problems that weren't assigned for homework in textbooks, or sometimes they'll have solved practice examples like in the text. So try solving these for more practice so that you don't just repeat the same homework problems over and over again to study. And definitely solve these without looking at the answers first, just because it is more helpful if you can go through and actually understand each step and do it completely on your own. Because in an exam, that's what's going to happen. You're not going to have the solutions with you where you can, get a hint in the middle of the problem. You're going to need to do it completely without those resources. So definitely don't look at the answers.
Yeah, I mean, most of your exam problems won't be problems you've seen before with different numbers. They'll generally be the concepts you've seen before, but approached in a totally different way. So if you looked at the answers while solving it, maybe that means that if that exact problem was on the exam, you could do it, but that's unlikely. So what you're doing with these practice problems is making sure you understand the concepts.
Yeah, so that's definitely the most important part. And then also brainstorm what you think you will be asked on an exam. So if you know your exam is going to cover acid and base chemistry, maybe you can start to think about some questions they may ask. And maybe those questions aren't what they ask, but it's still a good tool to help you organize the important concepts and start thinking critically about some of what you learned. And kind of along similar lines, it's important to kind of make an equation concept sheet. So some people will make like maps showing how different concepts are related to each other. So you could have one saying waves, and that's related to electrons, or something like that, right? And that's a great way to kind of link together all of these concepts, and will help you realize when certain equations are valid and when they aren't. Because often that's one of the trickiest parts of engineering classes is that you're kind of swarmed. You have so many equations, but then it's really hard to distinguish when to use which one. So kind of taking a step back and breaking down all of these different equations and concepts is going to be a really helpful tool. And in fact, a lot of engineering classes will actually let you bring one cheat sheet into the exam. So often this is required to do anyway. But even if it's not, it's definitely a really great thing to do just to study.
So there's a question in the chat. Could it be a right decision to ask what concepts will be focused on the midterm and final?
Yeah, I think that often the professor will explicitly go over that, and they will say everything from day 1 to day 15 is on the midterm. I've had some professors that absolutely hate that question, refuse to answer it, but that is, I think, a small fraction of them. Most will actually tell you sort of what concepts. And I even had some professors that would have a day of review before the exam where they would actually explicitly outline for us and kind of make this concept sheet with the class. And often GSIs would do that in discussion sections the week before a test as well, which is why it's so important to keep regularly attending discussion sections in class.
I think it very much depends how you phrase the question.
Yeah.
Like, I've definitely had students be like, what's going to be on the exam? And I'm like, clearly I cannot tell you that. But if you're sort of like, can we talk about like what you think is the most important? Like, can we go through like what you think are the overarching concepts? That's a great question. I love like talking to students about that.
Yeah, that's a good point. Phrasing is important because they're not going to want to answer if you're like, it's y equals mx plus b on the exam. They're going to tell you to go away. But
Yeah.
concepts, like is linear algebra on the exam, that they're more likely to answer.
Yeah. I definitely like always make that equations concept sheet, even if I'm not going to use it. Like, I feel like making that summary for yourself, maybe with help from your GSI or your friends, maybe by yourself, whatever works for you, like, that is how I study. I often don't end up looking at it after I make it just because I learned it by making that sheet. Yeah. Okay, so once you've studied for the test, you have to actually take the test. So take another like couple minutes in your breakout rooms, talk about sort of your favorite test taking tips of what you do sort of during the test to be as successful as possible. And then if you have any suggestions that you like, put them in the YouTube chat. Maybe let's take like one more minute to think of test taking tips, and if there's any you think you'd like to share, throw them in the YouTube chat. Okay, I'm going to start going through some of my test taking tips, but feel free to add more or ask questions in the chat as we go through. So the first thing to just broadly keep in mind is that whatever you're writing on a test, a GSI is sitting down and grading. And I am looking for things that you did that are relevant and correct that I can give you points on. And so one thing that means is that if you get the wrong answer and I like don't understand what you were trying to do because you didn't show any work, I can't give you any points. But it also means never leave anything blank. If you leave it blank, I have to give you 0 points. There's nothing I can do. Whereas if you even if you absolutely know that you're never going to get to the correct answer, if you know what step 1 is, I will give you a few points for step 1. And so it's worth, like, even if you know I would never ever solve this problem, it is totally worth writing down what you do know. Because if you don't, I will guaranteed give you 0 points. But if you do, you'll get something. And similarly, explain your work. So I had a student on an exam who like didn't have time to actually go through and do all the math, but he wrote a paragraph that was like, first I would do this to solve for x, and then I would put x into this equation and I would use that to solve for y. And he got like literally 80% of the points because he fully knew what to do. And so like he knew the concepts. This isn't an algebra class. I'm not testing your math skills. And so he got like almost all of the points by writing down 0 numbers. So you can get a lot of points that way. And also on the partial credit side of things, like if you get the wrong answer and what you've written down is like 10 random numbers with like no explanation of what they mean or where they came from or what you're trying to do, like I can't give you partial credit for that. Whereas if you write like, I'm trying to do a balance around this unit to solve for this value, I can give you a couple points even if you do that wrong, if that's like a good thing to do. So make sure your GSI will understand what you're trying to do.
Yeah, I think one of the worst things to see is if someone got the wrong answer, but it was like almost right, and you know that most of their steps were correct, but then they didn't show anything, and then they get like a 0. Whereas if they had written down their steps, they would get like a 9 out of 10, and that's really sad for everyone. So, yeah.
Like usually getting the correct final answer is like 2 points out of the total of 20 for this problem. So you can get like...
And usually one of those points is just writing the correct units. So.
Yeah. And sig figs. There's someone put in the chat, don't stay working on a problem you're stuck on. Finishing the ones you know how to do can help refresh your memory. That is super true. So that's the next one after this. But one thing that I always do is break problems into small sections, which is kind of related. Like if you know that like this whole problem seems super overwhelming, but I do know that at least the first thing I need to do is convert things into these other units. And then like sometimes like, okay, now I've converted them into units. I know that I'm going to need to plug it into this equation. And I don't know how I'm going to get there to the final answer, but like that's a useful thing to do. So like breaking them into small sections can make them feel more manageable and can also help you get partial credit. I like cannot emphasize partial credit enough. I've gotten A's on tests where I boxed no answers. Like I literally didn't get a single final answer for any problem. But like I did the first 60% of each problem, and that was enough to get me a good score. Would you say it's common that most GSIs want to give students points on exams? Yes, absolutely. Because like I taught you this material, I don't want you to do badly. I want to feel like I did a good job, right? Like I want to see my students like score well on the exams because that means I did a good job. So like it's absolutely true that as I'm grading exams, like I want to give students points.
And we actually sit down after exams and think about problems where everyone did poorly, and we take that more as a reflection on what we taught you and how good of a job we did than if you actually knew the material. Because that all that means is that we didn't do a good job teaching it, or it was a poorly phrased question. So we really are trying to give all the points we can.
Yeah, and I love the students that explain their work well, because then it's like really easy for me to grade and I can be like, yes, awesome, like, yay, you did things. Even if they're wrong, like, or like the math is wrong, it like makes it easier for me to grade, which makes me happy, which makes me want to give you more points. But also, it gets you more points. And I have spent like truly 20 minutes staring at one person's solution to one problem, just being like, I want to give you points. What are you trying to do? Like, I wish you had written a sentence telling me what you were trying to do. But like, I'm really like, I'm doing the math to try to figure out like what you did. So yeah, like I spend a lot of time just trying to be like, what did the student do? What do they know? What can I give them points for? Budgeting your time, super, super important. So this is the one that was put in the chat. Look at the point values. On tests, like there's 100 points, and if there's a problem if it's an hour, it's a 100-point exam, and there's a 10-point question, don't spend more than 6 minutes on it, because it's 1/10 of the exam points, and therefore 1/10 of the time. So if you have like a 1-point multiple choice question, give it 30 seconds, and if you don't know it, move on. So I definitely don't take my exams start to front. I literally like flip through the entire test, find the problem that I think is easiest, and do that first. Because then like no matter what, I've got points. So really think of exams not as like trying to solve all these problems, but trying to rack up points for yourself. So even if like you only know how to solve part D of a problem. Like, make up a number that's your answer to part C and show me that you knew how to solve part D, and you'll get the points for part D, at least most of them. So I can't tell you how many times I've seen students like, the last problem on the exam is the easiest one, and they just never got to it because they got stuck on problem one. So budget your time. Don't spend all your time on one problem. Really find what problems you think best will reflect your knowledge and get you the most points. And it definitely does happen that like you think one is really hard, you solve problem two, and as you're solving problem two, you kind of remember a key trick to solving problem one. And I think this is the last thing is translate words into like diagrams and equations. I think I can't speak for everyone, but I think like for myself and a lot of people who are engineers, like we work well with like equations and diagrams and less well with like reading a really long paragraph. So whenever, it's not like always applicable, but like for a lot of problems, specifically in higher level engineering classes, just taking that, paragraph of a question and drawing a diagram of what's going on, taking the information from that paragraph and like, oh, that means the height is 5, okay, like I'm gonna label y equals 5 here. And taking that information and turning it into equations, just so you don't have to go keep reading that paragraph over and over again. So I think I've seen a lot of students who like really know their stuff, but they just like don't have these test taking strategies, and they end up like not showing their knowledge and not getting a lot of points. So really like take advantage of that partial credit and like whenever you can, show us what you know. Like if you just write down like, I have no idea what's going on with this problem, but I know that like F equals ma is relevant because there's an acceleration and a force here, like I'll give you a couple points because it's true. Like don't write down F equals ma on a chemistry exam where it's not relevant, but like write down things that are relevant and true that you think would be somewhat useful somewhere in solving this problem, and you'll get a couple points.
Cool. So Berkeley is a big place. Someday, hopefully, all of you will get to actually come here. But there are a few things that you can kind of help do to get more involved outside of just taking classes. So one of the first ones is undergraduate research. So this is really nice because it can help you get to know a professor in the lab and then other graduate students and postdoctoral researchers in that lab. And then you can learn if like research is a good fit for you, which is really important because doing undergraduate research is actually necessary if you want to consider going to graduate school.
Not necessarily as a freshman, but
not necessarily as a freshman. Yes, that's a good point. But either way, it's a really good experience to have because it lets you apply some of the skills you learned in class, still in like kind of an academic setting where you're continuing to learn. So it's still like a great thing to have on your resume, whether or not you want to go to graduate school. But if you do even think that you may consider graduate school, still it's really good to get involved just to see if that's something you like. Like no one did undergraduate research or like internships at big oil companies in high school, right? So you need to kind of get all of these experiences in college so that you kind of know what you actually want to do with your degree. And that's something that is really hard to do, but there's a lot of, things at Berkeley that you can participate in that will help you kind of understand what you want to do. And the other thing is professional organizations. So there's quite a few organizations on campus, but it's always good to be a part of the society of your field. Someone asked, have you guys done any research? So we do research all day. And when I was an undergrad, I did research in a field that is actually completely unrelated to my degree now, but I still really, really enjoyed it. And it was a great experience.
Yeah. Like Katie said, we do research. I'm not sure if this question was directed at us or the other students, but we have done a lot of research. But I also, I did research in undergrad that was pretty related to the research I'm doing now. And honestly, I struggled a lot with, the classes in CBE in undergrad. I found them really hard. And probably, honestly, might have switched majors if I hadn't done research. And then when I started doing research, I was like, oh, wow, I love this. This is why I'm doing chemie. I love this research. I love how what I've learned in the classes applies to research. So I like, yeah, my GPA was like fine, but like what I really loved and excelled in undergrad was the research. It's like what made me love chemie and what made me go to grad school.
Yeah, it's definitely the fun part of the degree sometimes, is getting to actually apply it and see some of the cool things.
But I don't know, I've probably met like one or two undergrads ever who did any research in high school.
Yeah, it's so unusual, and no one expects you to have done research in high school or even as a freshman. Really, it's most common for sophomores and above to kind of have undergrad research positions, but it's never too early to start thinking about it or
If you know
asking
you're
GSIs.
interested in it,
Yeah.
yeah. Yeah, I started the summer after my sophomore year, but I wish I'd started earlier because I loved it so much.
Yeah, I started my senior year of college because I had no idea that graduate school existed for engineers. That was just something I never knew until one of my professors told me. And then I got involved in research and I loved it so much I applied to graduate school. So it's never too late to completely find a new interest and change what you want to do. Okay. But yeah, so professional organizations are also a really great way to interact with your field. So we're both part of the American Society of Chemical Engineers, but there's one for every single kind of brand of engineering out there. So some of you may be interested in the American Society of Mechanical Engineers. There's ones for civil and environmental engineering. So it's really important to get involved with these because the campus organization version of this will often have things like student panels where they can talk to you about future careers, like what you would actually do as a mechanical engineer if you went and worked in oil and gas, or what you would do if you went and worked in construction, or if you went and worked in sort of a biomedical type field. So it's still a really great way to kind of learn more about what you actually want to do with your degree, and then also interact with other people that have similar interests.
And there are clubs that are narrower also. So like chemical engineering is the one that we know best, but there's an organization called ChemiCar within chemical engineering where like you're on teams and you try to like build cars. And so like the people who are in chemie who are really interested in that side of things join that club. The people who are interested in the more bio side don't. They join something else.
Yeah, but there's a club for them, and that's great.
Yeah.
Yeah, and then it's also really important to kind of explore other interests. So you're here for your degree, but there's a lot of other great things at Berkeley too. So if you're really interested in like the environment, you could get involved with some environmental advocacy clubs, or if you really like education, there's a lot of volunteer opportunities where you can go and teach science in local schools. So it's really great to kind of do all of these other things too, just because that can help you kind of learn and grow and figure out other interests too. Okay. So then just to summarize the main takeaways. So the first one, the main important one, is that your GSI is very human. So we have good days, we have absolutely horrible days. We've all been to college for the first time and have been scared by it.
We make typos in our lecture slides.
Yeah, we too forget to put units on things. You know, we all make mistakes, and we're also really, really understanding when everyone does as well. We never think that students just are too dumb to ever get anything, because we've been exactly where where we had no clue what the photoelectric effect meant. Not too long ago either, because we aren't, you know, as old as professors, so really we were in your shoes, I guess, like
a couple years ago.
Yeah. Like 6 years ago? I don't know. We don't need to count it. So your GSI was once an undergrad too, which is why they can really relate to kind of some of the experiences that you're going through. So we do get it. And our job ultimately is to help you succeed. So we are actually paid for this, so it literally is our job. But even aside from that, most of us really are passionate about teaching. So we actually personally really want you to learn the most, and whatever that means for you. So please come talk to us. We can't read minds, so if you need help, we aren't going to be able to anticipate that unless you come and talk to us. So please do, never feel afraid. There is no shame in asking a question, even if it's been several months since that exam happened. We really just want you to get the most out of class. So yeah, come ask for help, and then we can really help you a lot. But we just need people to reach out to us simply because we just can't anticipate it otherwise.
So yeah, just wanted to make sure you guys have our email addresses. A couple of you have asked us if we're around to help you with Chem 1A. And the answer is sure, we'd be happy to try, but the GSIs who are running that class are probably your best resource just because like we won't have the homework answer keys, we won't like know what's on the exam, or like if you we won't have gone to lecture, so if you're sort of like what did he mean when he said this thing, I'll be like I have no idea because I wasn't there. So feel free to contact us totally if we can help you, if there's anything we can do, but your GSIs should probably be your sort of first line of help, just because they're going to be more useful. But especially if you have questions about grad school or research or anything we can help you with at all, we're always here and we want to be as helpful as possible. So that is the end of Chem Prep. We hope it's been useful for. There's a question, what class will we be helping in? So actually neither of us are GSIing this fall, but we'll be GSIing more like chemical engineering classes later. So if anyone ends up switching into chemi, let us know.
Yeah, let us know if you want to be a chemical engineer. We can help you.
But yeah, so we're gonna go to the Zoom room if you have any more questions. We really are sad that we didn't ever get to know you guys, and we probably wouldn't recognize many of your faces just because there hasn't been like Zoom with video that often. So if you see any of us on campus, like say hi, introduce yourself. We'd love to get to know you, and actually like see you.
Yeah.
But yeah, keep in touch. Please fill out the feedback survey, and that's it. So we're gonna go to the Zoom room.